Hello, I'm Edward Tarte, math teacher. I have discovered some mysterious arithmetic that I would like to share with you now, and then offer you the challenge of figuring out why it works. I invite you to participate actively in this video. If you choose to do that, you will probably need paper and pencil. If you have had at least a year of algebra and like math, this video may be for you. If there is a high school student in your household who has had Algebra 1 and who likes math, I suggest that you show this video to that student in the hope that he or she will be interested and perhaps be ready to participate and solve the challenge. After I offer you the challenge, you may, if you wish, pause the video or stop the video and then do your work on the challenge, and after that, resume the video and watch my solution. We start with a number. I write it down, then I write down the same number again, and then I write down another number. That third number could be the same as the first one, or it could be smaller, or it could be bigger. I choose bigger. So I write 11, 11, 16. Then I square the numbers. That means I multiply each by itself. 11 squared is 121. The other 11 squared, 121, and then 16 squared is 256. I add the two 121s, that gives me 242. Then I subtract 256 minus 242, which equals 14. And now I will use the opening numbers in a different way. I take the 16, add it to one of the 11s, which gives 27, and I write down the other 11. I square the 27 and I square the 11, giving me 729 and 121. I add those two numbers and get 850. I subtract that 14 that I got earlier. 850 minus 14 is 836. Then I divide that 836 by 2, which gives me 418. Then I divide 418 by the first number in the original group, 11. 418 divided by 11 is 38. The numbers that I began with, 11, the second 11, and 16, add up to that same 38. And that's not a coincidence. It works with any group of numbers that you begin with. So if you're interested, you could try numbers of your own choosing and follow the same pattern of operations that I did and verify that it continues to work. So your challenge is show algebraically why this works. If you want to now, you can pause or stop the video, do your work, and then resume the video and compare your work with my solution. So here is my algebraic explanation of why that mysterious arithmetic works. We begin with a set of numbers A, and B. We square each of them, which gives A squared, and B squared. We add the A squared and the A squared, which gives 2A squared. And we subtract. That's B squared minus 2A squared. Then we return to the original group of numbers and use them in a different way. We take A plus B and A. We square both A plus B and A. Squaring the A plus B means multiplying it by itself. That's A plus B times A plus B. That gives us A squared plus 2AB plus B squared. We add to that the A squared. Then we take that expression and from it we subtract what we got up here. We subtract the B squared minus 2A squared. In order to do that subtracting, we distribute the negative sign to what's in the parentheses, and we combine like terms. The plus B squared and the minus B squared add up to 0, so they disappear. The 2A squared combines with this 2A squared. We get 4A squared plus 2ab. Then we divide that by 2 and we get 2a squared plus ab. Then we divide that by a, and one of these a's disappears and this a disappears, and we get 2a plus b, which is, of course, a plus b. That's the sum of these numbers that we started with. And so that's how I show algebraically that my mysterious arithmetic works. I hope that this video has given you mental stimulation and pleasure. Thank you for watching.